Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 4th, 2026, just yesterday. It introduces ERNIE 5.0, a massive trillion-parameter foundation model that successfully unifies multimodal understanding and generation across text, images, video, and audio within a single autoregressive framework. The paper is titled ERNIE 5.0 Technical Report. And as we'll see later, the implications for deployment are quite significant, especially regarding their new elastic training method that creates multiple model sizes from a single run. Figure 1 illustrates this unified architecture. Starting at the bottom, inputs like text, images, and audio pass through distinct encoders and embedding layers to be converted into a shared token format. These tokens then move into the central block, the unified transformer layer. Inside, a shared router directs tokens to specific feed-forward experts, which are specialized processing units that handle different aspects of the data. Finally, the top section shows how the process signals branch out to specific heads and decoders to generate the final output. Building on that general layout, Figure 2 zooms in on the specific pipeline for visual tasks, illustrating how the model handles both understanding and generation. On the left, we see the understanding workflow. An input image passes through a hybrid encoder, which combines a convolutional neural network and a vision transformer to capture both fine details and global semantics. Then, shifting to the right, the diagram maps out the generation process. Here, the researchers introduce a technique called next frame and scale prediction. This approach treats image generation as predicting the next resolution scale, and extends that to video by predicting the next frame in the sequence, effectively unifying spatial and temporal modeling. Well, enabling that flexible deployment requires a unique training strategy, which Figure 4 lays out. This is the elastic training framework, designed to optimize the model across 3 different dimensions simultaneously. On the far left, the diagram illustrates elastic depth, where the training process randomly deactivates layers, shown as gray blocks, to ensure the model remains effective even if it is later pruned. In the middle, we have elastic width. Here, the system varies the total number of experts available in the mixture of experts layer, forcing the network to perform well with a smaller expert pool. And on the right, the figure shows elastic sparsity, which changes how many experts are active per token, known as the top K value. By mixing these configurations during pre-training, the team produces a single model family that can adapt to different memory and latency budgets without needing to be retrained. So, moving from the training architecture to actual performance, Table 1 compares the pre-trained ERNIE 5.0 base against strong baselines like DeepSeek v3.2 and Kimi K2. Looking at the knowledge category at the top, we see substantial margins. For instance, on Chinese Simple QA, ERNIE scores about 90, clearly outperforming the others. In the middle sections covering general and STEM benchmarks, the model continues to lead, notably achieving over 75 on MMLU Pro and nearly 74 on the math chain of thought tasks. Finally, the coding section near the bottom reveals a massive jump on Human Eval Plus, where ERNIE reaches roughly 81%, validating the unified autoregressive approach. While the previous results focused on the base model, Table 2 evaluates the fully post-trained versions against top-tier competitors like Gemini 3 Pro and GPT-5 High. In the knowledge category at the top, ERNIE 5.0 secures the highest scores, reaching 74 on Simple QA and 86 on Chinese Simple QA. Scanning the STEM and coding sections in the middle, we see that while Gemini 3 Pro often takes the top spot, ERNIE remains highly competitive, scoring nearly 95 on Human Eval Plus. Finally, looking at the instruction-following benchmarks, the model reclaims the lead, achieving the best performance on multi-challenge and multi-IF, which highlights its robust ability to handle complex directives. Wrapping up, ERNIE 5.0 marks a significant milestone by demonstrating that a single autoregressive model can unify understanding and generation across all modalities, without falling victim to the typical performance trade-offs. Perhaps even more importantly, the elastic training paradigm provides a scalable solution for deploying these trillion-parameter giants in real-world, resource-constrained environments. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.